Good morning to all of you. I welcome you to this session of programming in Python. In today's session, we are going to discuss about lists in Python. Okay, we'll be discussing about lists in Python. So what is a list? Basically, list is a sequence of items, okay, enclosed in square brackets. In Python, list is a sequence of items enclosed in square brackets. So we'll be discussing how we can create the list elements using the list class of Python and what are the other ways of creating lists. Then we'll also discuss that lists are mutable and mixed lists are possible. That means you can have a list which can contain integers, floats, and strings together. Then we'll be discussing about the index operator. Okay, so there is a positive and a negative index associated with the elements of a list. Then we'll see how we can do the traversing of a list with the help of the loops. Then we'll be learning about the list slicing and the step size. We'll also focus our discussion on the list operators and some inbuilt list functions. So this would be the idea like for the first 20-25 minutes. So for that, I'll now just take you to a Python session. I'm opening the Python ideally for you. So first of all, the very basic way to create a list would be to use the constructor of the list class, right? So I can use this way to create a list. So I've created a list with 3 elements. I need to enclose them in square brackets, right? And this list is the constructor of the list class. Okay, you pass these elements to it, it will create a list out of it. So if you see it, it displays the list like this. And if you see the type of this, it will tell you that this A is a list that you have created, right? Then there are other ways also. We can use some other ways. You know, we can create a list from a string by using the range function, okay? And we can do it without, using the constructor also. So let's see that. I can simply, create a list like this also without using the list constructor. If you see, the type again is the list. Okay. Then I can also create a list like this, say b is equal to let's see if we can do this range function here. Okay. So obviously we need to populate the elements there. Okay. We'll be using some list comprehension to create an actual list using the range function. But then you can populate the values of in a list with the range function. You can also use a string. Okay, a string here. So if I use a string here, say like this, okay, then you have a list like this, okay. And if you see, the idea behind the list is similar to the idea that you've learned in C++, is that of an array, okay. The only difference here being that we can have a mixed list also. So have a look at this. We can have a list like this also, which is not possible in languages like C and C++. So this is an example of a mixed list in Python. Okay, so you can see the type here. This is a list. Okay, so we can have mixed list also. Next, we see that lists are mutable. Mutable means that you can vary the elements of a list. Okay, so mutable is something which can be changed. Immutable is something which cannot be changed. So lists are mutable and mixed lists are possible, right? Okay. Then we have an index operator. To access the elements of a list, we have some indexes, which we can use. the first index in a list is 0. Okay, so this element 1 is at position 0, this element 2 is at position 1, and so on. So if I just write here D0, it will print 1. D0, that is the first element of the list. So the indexing starts from the 0, right? The first element is index 0, next element is number 1, and so on. Similarly, if you look from the back side, okay, the first index from the back is -1. So D -1 here would be Sharma, right? So this is the negative index. Okay, if you want to see from the reverse side, this is -1, this is -2, this is -3, and so on, right? So let's try to use this. So if an index is not available, then an list index out of range error is given, right? So we have discussed about lists, how we can create it using the list constructor. Lists are mutable, that means you can change them, you can alter them. Then mixed lists are possible, okay? And to access the elements of the list, you need to use the index operator, where the first index is 0, okay, and then the indexes increase like 0, 1, 2, and the indexes from the backside or from the reverse would be -1, -2, and so on, right? So if we see that if we have a list like this, like we created a list like, say this, we gave a string here enclosed in square brackets. So now this list contains only one element, that is a string element Ajay Sharma. So if you do like this C0, it's like this. If you go in for C1, there is no C1, right? But if you want a string, you know, each character of a string to be a part of a list, then you can use this functionality. You can use the list constructor and you can pass some string to it, right? Like this. So now if you look at D, it's like this. Each character of the string is a element of the list. This is a difference like with this normal, you know, string passing and through the list constructor. Similar is with the range function. If you go with the range function here and you use the list constructor. So if you write here, say range 5, so you can see that R is populated with values 0, 1, 2, 3, 4. Because you understand the meaning of range 5, you have not given any initial value, so the initial value starts from 0 and goes up till 5, and 5 is not included, right? Similarly, if you use like this, say 2, 6, then you can see the elements from 2 to 5. And if you do something like say 2, 16, 4, then you can obviously see the things. The step size is 4 here. So the list is created with the value starting from 2 going on till 16, 16 not included, and in steps of 4. So these are the ways in which you can initialize, you can create your lists. So let's now see how we can traverse a list with a for and a while loop. Okay, how we can traverse a list. So let me just create a list first of all as a sample here. Okay, so with the for loop, it's very easy. You can just start here for I in, you can simply write the list name here, right? And you can print it. Okay, you can just parse through this list by taking a variable in a for loop, say for I in S. So with this, I can traverse each element of this list as starting from the first element. So if you print I for the first time, 1 is printed, then 2, and then so on. And once the list ends, this for loop will be terminated automatically, right? Okay, so this is how you can traverse a list with the help of a for loop. Similar is the idea with the while loop. You can just initialize a variable I here, and then you can write here I is less than, say, length of S. So I'm discussing one list function, that is length. So I is less than length of S. Okay, and then I can print, say, S I, and I can increase I by 1, something like this. Okay, So I is 1. This loop will run till I is less than the length of S. The length of S, you understand, is 5. There are 5 elements. So this will run 5 times, and the first time around it will print S of 1. Okay, we can start here with 0. Yeah, we need to start here with 0. Yeah, I'll just correct it. So we can start here with 0 because 0 is the first index. And again, we can see this while loop here. Okay. And we can see that we have traversed all the elements of the list. So I is equal to 0, referring to the first index. This is the condition for the loop to run. And S0 first, then S1, then S2. And obviously S0, you understand, is 1. Okay. 0 is the first index in a list or a string or whatever you work, whatever sequence you work in Python, the first index would be 0. So this is S0, this is S1, S2, and so on. And when you see from the reverse, this is S of -1, that is 5, S of -2, S of -3, and so on, right? So this is how you can traverse the list using the for and while loops, right? Then one thing, lists are mutable. That means they can be altered. Kindly keep this thing in mind. I'll be discussing something regarding it soon, right? Then let's see what is this list slicing, right? Let's come to list slicing. Slicing would be we need to extract a part of the list, okay, by specifying some parameters, right? So let's see how we can specify the slices. Obviously, a slice would be some starting value and some ending value and a step size, okay. So let's see this list S. If I want to see a slice, say 1, 3, okay, that would mean index 1 to index 3, but index 3 not included. So you see, this is index 1, this is index 2, this is index 3. So the output of this would be 2 and 3, right? So this is a slice, a part of the list, okay. Similarly, you can write something like this, okay, or maybe we can take a bigger list here so that things are clear. Say I can take a bigger list here, okay. Then if I take a slice like this, say 2 colon, okay, just keep on noting 2 colon. That means starting from the second index. I've not mentioned the ending index. So starting from second index, what is that? That is 3. So 3 till the end of the list. Okay. Similarly, I can also write like this. Okay. Right. So that means I've not mentioned the starting index now. I've mentioned the ending index. So starting index is automatically taken as 0. And we go on till 2, but 2 index is not included. So what would be displayed is this, right? Kindly have a look here. Understand all these scenarios, in which we can pick up the slice from a list. Okay, let's now try this. Okay, so starting from second index, going on till 6 index won't be included. So with a step size of 2. So index 2, index 4, but 6 won't be included. So what is index 2? This is index 2 and this is index 4. So the output of this would be, okay, sorry, this is index 2, I suppose. 0, 1 and 2. Yeah, this is 2, this is 4, this is 6 index. But 6 is not to be included, right? Okay. Let's go from the negative side now. Say -1 colon 0. Colon -1. So can you make a guess what it would be? Okay, so I'm saying start, this would print the list from the reverse order. I'm saying from the reverse, go till the beginning with a step size of -1. So our first guess would be that this would print the list in reverse order. But kindly see that we need to go till 0, but 0 is not included. 0 is not included. So it will print the elements 9, 8, 7, 6, 5, 4, 3, 2. 1 won't be printed. Kindly note this thing with this slice, right? Similarly, if you want to print the entire list, okay, in reverse order, you can do like this. Okay, this would be the list in reverse order, right? Okay, kindly note this is the list in reverse order. And if you want to print the entire list without this, so this can be done in the normal order from beginning to end. So you can use this also. So kindly note, see how we can extract slices from a list. The same would be when we are discussing strings, the same idea would be there in case of strings also. Okay, so this is how we can pick up a slice from a string, right? One more thing I would like to discuss, I'm just going to mention a formula here, like if you're looking for a negative index, how we can pick it up. Okay, so if we have a list, say, if we have a list, then list the negative index, say minus n, you know, that would be equal to, use this formula, list length of L, okay, length of L, and it should be minus n, right, like this. Okay, we'll be using this formula here. I've written a formula here if you need to calculate the negative index. Okay, let's check it. See, our list is S, so if I want to check for S of -5, okay, then S of -5 would be S of, first the length is 9, so it would be 9 minus 5. Okay, that would be S of 4. Okay, S of, you can see S of -5 is equal to S of 4, that is, this would be the element, the 5 would be the element. You can see here -1, -2, -3, -4, -5. This is the S of -5. From the positive index, it would be S of 4. You can see 0, 1, 2, 3, 4. So kindly remember this formula if you need to calculate the negative index of a list. If you need to look for an element starting from the reverse, then you can make the use of this formula. Okay. So let's now see what else we can do. We can discuss the list operators. Plus, star, is, in, and del. Okay, let's work on these now. So plus would be there to add two lists. Okay, let's take an example. Say there is one list A, there is another list, say B. Okay, so if I write here A plus B, it would be the combination of these two lists. The A and B would remain the same here because you're not allocating them to anything, right? So if you do something like C is equal to A plus B, then obviously C would be the combination of this. So the plus operator is used to concatenate two lists. Similarly, the multiplication operator is used to repeat the elements of a list. So if you see A here, and if I project A as A star 3, you can see that the list is multiplied thrice, 1 to 3, 1 to 3, 1 to 3, like this. Okay. Similarly, if I write here A star 10, you can, sorry, if you see here A star 10, then you can see the elements like this. This is the star operator, right? Then we have two operators, is and in, right? Is and in. So these are the this would help you in checking about the idea of the mutability of a list, right? So first of all, if we look at the list, say C, and there are the 6 elements in C, right? So if I write here 3 in C, it would return me a true value. So I'm suggesting that this element 3 is present in the list C. So this is true, so it will return a true. Similarly, if I write here 8 in C, it would return a false, right? Now, what about the is operator? Okay, is operator, right? Let's have a look at the is operator. Say I have a list here A 1, 2, 3, right? And then I have a list as again B as 1, 2, and 3. So I've taken two identical lists. If I use the equality operator, it would tell me that this is true, that A is equivalent to B. They are having the same elements. But whether they are pointing to the same object in memory, okay, whether they are pointing to the same object in the memory, we check that with is operator. A is B. Okay, so if I write here A is B, it will tell me false. That means even though A and B are having similar values, they are different objects in memory, simply because A and B are mutable. So if they would have to be the same object, right, then if you make change in one, the other one loses its credibility, right? So you can check that they are different objects with the id function. So id of a in memory is this. Similarly, id of b is this. You can see they are different ids, they are different objects in memory, even though they are having similar values. We'll see this thing in case of strings. Like if two strings are, similar, they have the same IDs and they point to the same object, because strings are immutable. Whereas lists are mutable. You can alter the list. You can change the lists. We'll see certain list functions which would make this point clear. So right now you can see that even though A and B are having similar values, we say they are equivalent. A and B are equivalent, but they are not pointing to the same object in the memory. They have got different memory locations, as you can see here, right? Next is the del operator, right? So if you need to delete an element of the list, you can just use the del operator like this. Say, let's have a look at the list first. Say, let's pick up C, okay? Then I can use something like del. Let's see how we can use this C2, okay? So if I now look at C, you can see the second index element. So this is index 0, this is 1. This has been deleted with this del command, okay? And let's try to give an index which is not there, say A12. Okay, so it will give you an index error, or assignment index is out of range error, right? And if you simply write del A, okay, then A is not existing anymore because the entire list has been, oh sorry, I'll just write it with the C, I think that would make it clear. Yeah, okay, so same as the C is not there. Del C, if you don't mention any index with the list, then it would delete the entire list, okay, and you cannot recover it. So kindly use this del command with caution here. So we have discussed these list operators. Plus, star, is, in, and del. Kindly see how they are used, these operators. You write the argument like this. So see the variation when we use the list methods. We would be using the methods in a different way. Then there are certain inbuilt list functions, len, min, max, sum, and say random dot shuffle. So I think by name they are clear, but just have a look at them. Say we have got a list here, T, say 1, like this. So if I look for the length of T, it would be 5. If I look at max T, it would be 5. If I look at min T, it would be 1. Okay. And what else is there? If I look at the sum of the elements, it will sum of the elements of T, right? And if I want to shuffle, obviously I can write something like random dot shuffle, and then I can put T here. Okay. Yeah, we need to import the random module, obviously. So we'll just import the random module. We can either use it like this. We can import the random module first. Then we can pass this list T to the shuffle method. Okay, it will just rearrange the list. You see, 1, 2. So this would prove here that lists are mutable. You've changed its position. It can be altered, right? Again, if you shuffle it, then obviously it will again shuffle it. Okay, you can also use this with this, say from random import. You can use this method, import shuffle, and then you can directly call shuffle. Okay, that would be an easier way to use if you need to use it a number of times. Okay, look here again, it has shuffled. So this is regarding the inbuilt list functions that we have discussed. So let's now move forward. Let's now discuss something about list comprehension. That is the next part of our lecture, list comprehension. And then we'll be writing a few scripts based on this list comprehension. And then at the end of today's lecture, we'll try and discuss all the functions, that is the list functions, append, clear, count, the list you can see on screen. So what is list comprehension? List comprehension would be a shorter way of writing your Python code with respect to lists. Okay, so I'll take an example here for you. What exactly is list comprehension? Say for example, I have a list, say x is equal to say 10, 20, 30, 40, 50. I have a list there with me. Okay. So if I want to print the even elements of this list, okay, if I want to print the even elements of this list, I can write something like, say for I in x, okay, and then I can write something like if I percentage 2 equal to 0, then I can write here print I, right? So obviously this will print all the even numbers. We have all the even numbers, so we can't see the difference here. I'll just put some odd numbers here. I'll put some more elements here like this. Okay. Then again we can pick up this functionality here. So you'll see it will print all the even numbers. Okay. Now this is the normal way that you do programming. Within a for loop, you take some if and you do some functionality here. This can be done with the help of a list comprehension also. Have a look here. So you can take some value here, say list comprehension. The topic is there, expression for element, right? In sequence if conditions. So here you write some expression what you wish to see from which list or which sequence, and then you can specify a if condition. So let's see how we can do it here, right? So I can write here x for x in, take some different variable here, say y, so y in x if x percentage 2 equal to 0. So there's a concise way of. So when we are looking for the list comprehension, you see we write here, we pick up some variable or expression here, and then we let this variable pass through the list or the sequence from where we want to extract another list. So y for y in x, x is our this list, right? And so y would be visiting each element of this list x, and we check whether y is even or not. So it will print the even elements. Similarly, I can write here if y percentage 2 is not equal to 0, and then if I see, then I get all the odd numbers, right? Similarly, what I can do here is I can pick up this problem here, generate lists, 3 lists where A is a list of squares from 1 to 10, B is a list of cubes from 1 to 10, and C is a list of elements which are even and are present in A. Okay. So let's check this thing. Let's see how we can write this list comprehension code. Otherwise, I know you can write it, but how to write it using the list comprehension? So we'll be creating these 3 lists A, B, and C. First, let's create this list A, which is a list of squares from 1 to 10, right? Okay. So let's go for A. So I can write here A is equal to, okay, so I would be going for exponential operator x square, right? And then I can parse x in the range that I require. What is that range? From 1 to 10, right? So range could be 1, 11 here, right? For range 1, 11, I think that would be fine. Yes. Okay. So if you look at A, it will have the squares of all the numbers from 1 to 10. You can have a look here. A is a list of squares from 1 to 10. Similarly, B is a list of cubes from 1 to 10. Okay, so let's have a look at B here. I can simply make a change here, say a cube here and a B here. Okay, so if you look at B now, you see it's a list of all the cubes from 1 to 10, right? And then we require C. Okay, let's have a look at what we require in C. We require C is a list of elements which are even and are present in A. Okay. So we need a variable to parse through the list A and check for the even numbers, right? So that's what we have done just now. You can write here C is equal to say X for X in A if X percentage 2 equal to 0. So this would be our third part. Okay. So it has picked up those elements from A which are even. Okay. With that, how it picks up the elements in A? We take this variable X for this purpose. So we parse X from the list A. Okay. So it picks up A first as 1, then 4, and it checks each time whether it is even or not. And it puts only those elements in the list C which are in A and which are even. So this is the idea behind list comprehension, right? So I think this is good about list comprehension. You can write your code in a compact way. Just remember this, that you need to have some expression. Then you parse that thing in a list, in a sequence or a string, whatever you wish, with some condition, right? So you see the different functionalities here. The expression here is simply a variable y. The expression here is x square. The expression here is x cube, and so on. Depends upon what problem you have, then you can decide about using that variable or expression, right? So let's now discuss about these list functions. I'll discuss them one by one. The first function is append. Okay. So let's have a look at the append function here. So let's say I have a list here. Append would be adding an element to the list at the end. Okay. So if I write here a dot append, say 77. So if I see the element 77 is appended at the end. Append would be adding at the end. All right. Then the next one is clear. Clear would remove all the elements of the list. So I can write here a dot clear. If I look at A, it's an empty list now. All the elements have been removed. Okay. So let's create A again, and then count. Okay. So I can use count like this. It would count the number of occurrences of the object that you mentioned in your list, right? So 33 occurs only once. You can put multiple values here to see the output. Okay, and if I write here a dot, now it tells us that 33 occurs thrice in our list, right? Then next is copy. Okay, so copy would be simply making a copy of your list. So if I write here b is equal to a dot copy, right, then b becomes a copy of the a, right? And if I use extend, okay, so extend would be like one list is added at the end of the other list. So let's look at the list A and B. Okay, let's just shorten B here. Say B is, let me give these values. This is B. So this is A, this is B. So if I write here, say A dot extend B, okay, see what happens to A. B is added at the list is appended at the end of the A. So entire list is appended, okay, and B obviously remains the same. This is what extends does. Extend. The next is the index. Obviously, index will tell you. I'm sorry. Index will tell you the index of the first occurrence of the object. So let's check here. Say A dot index 33. So obviously 33 is here at the second index, right? So let's see. So index 2 is returned here. The first occurrence, 33 occurs here also, but it returns the first index, right? Okay, next is insert. So insert is interesting. We can insert an element at a given position. Okay, so kindly note this thing carefully. This is our list A. So if I write here A dot insert, and I write here 0 comma, say this value, right? Okay, then this is inserted at index 0, and 11, which is already at index 0, moves to index 1. You can see it here now. Okay, so insert here, first would be the position, next would be the object that you want to insert. Similarly, you can insert, say 86 at the fourth index. So what is the fourth index? 0, 1, 2, 3, 4. So it would be at the place of 86, at the place of 44, and 44 will move ahead. You can have a look here. Okay, so you've inserted 86 at this position. Okay, but when we look at the negative indexes, right? So let's have a look at this a dot insert and say -1, comma 444. So obviously, if I just insert it, so this, it would be inserted between 777 and 999 and not at the beginning. Okay, that's the difference here. So if you look here, -1, you would be tempted to think that it would be inserted here and 777 will move to -2. It's not the case. Kindly have a look. It would be inserted like this, right? I hope this is clear to you about insert. The next is pop. So two things are there, pop and remove. Both of them remove the element from a list. Okay, delete the element from the list, but pop would display the element before deleting also. Okay, and you need to mention the index. Okay, if you don't mention this I here, then it will pop up the last element of the list, right? Let's look at pop. A is the list here, so a dot pop, say 0. Okay, so it will show, first it has displayed, it returns this value that it has popped 865, and obviously 865 is no longer in the list. Okay, and if I write here a dot pop just like this without any index, then 777 would be removed. You can have a look at this, right? Similarly, we have remove. So let's see how remove works. Say we have a here, and if I write here a dot remove, what we need to write here is position. Let's see, say 11 we write here. Okay, so we need to mention the object that we need to remove, right? So a dot remove 11, 11 is removed, right? And let's check here, a dot remove 33. Okay, so the first occurrence of 33 is removed, right? So let's see if an object is not there, if there is some error. Okay, so a dot remove, say 967 is not there. Let's try this. So X is not in the list. So if the object is not in the list, an error would be raised here, right? Okay. The next is, I think we have finished all, right? We have finished all the list methods. Yeah, reverse and sort is there. That would be simple. Say A is this. So if I write here A dot reverse, it would reverse the list, right? It will reverse the list, you can see that. And if I use here A dot sort, then it would sort the list in ascending order, right? That is the idea with the reverse and sort. So you see, we have done all the methods, the list functions or the list methods. So they would be helpful to you in writing certain programs, right? So you can take their help right there. Okay, I think that should be the end of today's session. And in my next lab session with you, we'll be working with problems based on lists. Till that time, keep watching my videos. Thank you very much.